Attention.
Party people! We about to go stupid now. Let's get dumb. Then get dumb. Let's get dumb. Ole, ole. Let's get dumb.
Good day. I'm Reverend MEDINA. I'm here to present to you the method of proof and disproof. So, one method of proof is the direct proof. A direct proof is one of the most familiar forms of proof. Using the proof statement of the form if P then Q, or P implies Q, which can be written as this arrow here means implies. And the method of this proof show original statement P, which we are shown to be true, and use it directly to show that another statement Q is true. Here is an example. Prove that the product of any two odd integers is odd. Example, 1 and 3. They are odd. If you multiply them, the product is 3. And 5 and 7, the product is 35. But even though how many million times you show it, it is still not considered to be true. So we have to prove it. So prove. Suppose m and n are any odd integers. Then the definition of odd numbers we have m is equal to 2r plus 1 for some integer r. And n is equal to 2s plus 1 for some integer s. Then with the substitution, we have n times n equals to 2r plus 1 times 2s plus 1. Now, to get the next answer, we will do the FOIL method. So, 4rs plus 2r plus 2s plus 1. And to get the final answer, we will use the distributive law. 2 times the quantity of 2rs plus r plus s, then plus 1. So that's the final answer. Now, the quantity of 2rs plus r plus s is an integer because the sums and products of two integers are integer, and 2, the r and the s are also integers, and therefore by the definition of odd numbers, m times n is odd, and that's the proof. Now let's move on to the method of disproof. The most used method of disproof is the disproof by counterexample. So, a counterexample is merely a way of showing that a given statement cannot possibly be correct by showing an instance that contradicts a universal statement. In short, a counterexample is an example that disproves a universal or for-all statement. Now, here is an example. For all positive integers n, if n is prime, then n is odd. Recall, to show that a given statement is false, all we need to do is to show that the negation of the given statement is true. And the negation of the above statement is this. There exists an integer n such that n is prime and n is even. By the way, there exists has a symbol of like this. It's like an E, letter E that is reversed. Now, keeping this in mind, let n be equals to 2. Then n is prime and n is even, because 2 is prime and 2 is even. Hence, there exists an integer n such that n is prime and n is even. And so, the given statement, which is for all positive integers n, if n is prime, then n is r, is false. So that's all. Thank you for watching.
저 달이 타오를 때면 소리쳐 라라